So we're at that point now where we have everything: stretches, reflections, and translations. Think about it. We've done stretches, we've done reflections, we've done translations. Let's put them all together. But wait a second. What order do they go in? Does it matter if you do a reflection first or a translation first? Well, yes, it does. As a matter of fact, we have to follow, like the rules of BEDMAS, in order to transform a graph, we have to make sure that we follow a specific order of operations. And they are, of course, stretches, reflections, and then finally the translations. SRT, that's the best way to remember that. Just like BEDMAS, you have another thing you got to remember, but this will really, really help you in the long run. Okay, so here's a couple things that we've got to talk about here. When does it not matter? Well, if you do two translations together, right, you're moving left and up. Okay, that's all right. You can kind of combine them together and do them all at once. If you're doing two stretches, a horizontal and a vertical, yeah, well, guess what? You can combine them together and away you go. You can do two reflections at once. That's no problem. And you can do, surprisingly enough, like we did on an earlier podcast where we did a reflection and a stretch all at once. Remember when we took a y value and we multiplied it by a -3, which include the stretch factor and the reflection all built into one? That's fine. But the most important thing that you have to do here is this. You have to remember to accurately sketch any graph, put it in the right form. If you don't have it in the right form, everything falls apart at this point. Okay, so what does this mean? Well, let's keep on going and I'll show you. Okay, so here's one of the most important things that you can see in this. The right form includes the letter, or I should say the number right up front, the coefficient right in this bracket has to be a 1. So in other words, you have to be able to factor out if this b is in there and there's no bracket, for example, it's like bx minus h, you can't have that. You have to be able to factor this b out so it is in fact a bracket. I'll tell you what that means in a second. Take a look at this example and you'll see it right away. Look how this looks like what we're after. We have the a value here. It's okay. We know it's going to be a stretch. We know it's going to be a reflection. Then we have a half here and we say, oh, okay, that's the b value, but it looks like we're going to translate 2 units to the left. Guess what? Wrong. No, it's not. One of the reasons why is, let me show you why. Take a look and compare it to the guy up here. Ready? Watch. Boom. It looks an awful lot like this one here. Right there. Do you see it? Okay. So it looks a lot like the same. The only problem is where's the brackets? Where's the brackets in this one? The brackets are missing. So what does that mean? Check this out. If the brackets are missing, you have to take this function here, or this part of the function, and you have to factor out a -1/2. Now remember, when you factor, factoring is like division. So in this particular case, you're going to divide out from both these terms, this one and this one, you're going to divide out a -1/2. Okay, well, here we go. Grade 7 fractions. If that means you're going to divide by a fraction, you multiply by the reciprocal of that fraction. So you're going to actually multiply these guys all by -2. Now, okay, so watch this. If you divide out a -1/2 from this, take a look. I divided out a -1/2 from this guy here. Okay, so if I take out a -1/2, look what I'm left with. I'm left with x. But now I got to take out the -1/2 here, which leaves you with a positive. Okay, now here we go. Ready? -2, that's this guy here, divided by -1/2. Okay, I can do this. Right. -2 times the reciprocal, which is 2/1, still a negative. This works out to be a +4. Check this out. This guy now is not -2. It's actually a +4. Oh my gotcha. If you don't take out this thing, you don't take out that leading coefficient there in that part of the function, you actually do the wrong transformation. Dun, dun, dun. So this is actually, if we look at the proper way of writing this function, we have y equals 2, and I'll just clean it up so that you can see it. That's this guy right here, okay? That's going to be y equals 2, negative 2, f of, now check out, the leading coefficient in this part of the function is negative a half. That's going to be x plus 4. There you go. So what does this mean now? Yes, vertical stretch of 2. We're also reflecting over the x-axis. This is a horizontal stretch. Don't forget to flip that one now. That's going to be of negative 2. So we're expanding horizontally and we're reflecting it. And guess what? Oh, forgot one of the brackets. And guess what? We're moving 4 left. Oh my goodness. Holy smokes, that's a lot to kind of absorb into your brain. My point here then, folks, is to stop the podcast and I want you to go back and I want you to look at this again. That becomes imperative, folks, when you're doing this. Absolutely imperative. Look at this section, last 3 or 4 minutes, and really burn this in. I'm going to do some more examples later on, but I think it's important that you stop right now, go back and watch this again. Okay? I'll wait. Are you doing it? Good. Okay. Now, let's go on to this. What happens to mapping notation? What happens to replacement notation? Well, I'm going to tell you right now, in replacement notation, we don't really look at all of this too often. This part is seldomly discussed. But the mapping notation, absolutely critical. Think about what's happening. With S, R, and T, think about what happens to the point X, Y. Okay, so first thing, you got to stretch it. So if you stretch it, you're taking every X and you're stretching it by 1 over B, right? So that's the X. And then you're going to reflect it. Well, that's absorbed into the B because then you could just make it negative, right? You're going to translate it then by adding all the H values to the X. Holy smokes. And then next you're going to do the same thing to the Y. You're going to take every Y value and you're going to multiply it again by the stretch factor. And you remember that's AY. And that includes the reflection because that could be negative as well. And you're going to translate it. You're going to add K to it. And it kind of gives you a formula for finding out the points. We're going to talk about that an awful lot. Now, what if you're asked to show a replacement notation? No problem. That's not an issue. I'll show you how to do it. It's just really not too big of a part of the course. But just in case somewhere on something called a diploma exam, okay, you have to be able to get in there and say, ooh, I know what they're talking about. Check this out. If you do the formula, which is y equals to a f of b bracket x minus h, right, bracket plus k. Remember, we like to get rid of this k and bring it over and have emphasis on the y. Okay, so y minus k equals, now look what we have. This is what we've had before, right? This is what we had written a couple times already. Boom. But check this out. I can divide both sides by a, right? Leaving me y over k, now that counts as out, leaves me with y minus k over a equals to f of b x minus h. Look, there's the replacements. There's your replacements. Y becomes y minus k over a, which I just happen to have, whoops, except I covered it up, right there. See how it becomes this? And then x becomes this mess. See? There's your replacement. Now, the thing is we very seldomly see it that way. Almost never. So they like just to bring the A over to the other side and put the A there and put the A there. That really, really helps with things. Okay? Got it? All right. So let's take these things now and realize one important big aspect to all of this. Okay? Huge aspect to all of this. Remember, this is a function. So a function could be anything. It could be a quadratic function where it's y equals to x squared. It could be a cubic function where this is now cubed. This could be an absolute value function where you take this guy here and you go, okay, bada boom, absolute value. You can make this into any function you want. So let me show you what some of the possibilities are going to be. Ta-da! Wow, check this out. Here's a quadratic function here. There's our standard one. Now look what happens. This becomes something because we're going to put all kinds of transformations on this. So check this out. Same silly formula over and over and over again. There's your a value, there's the x minus h value, there's your k, but that's what makes it a quadratic. Look at cubic functions as well. Look, the only difference is same. The only difference is the function is now cubed. Look at the absolute value function. Same thing. Same. The only thing is this guy's absolute valued now. Oh, whoopee-doo. Okay, look at this. Square root. Oh, here we go. There's a square root in it. Oh, my gotcha. This is like so bizarre. But some of them can be quite interesting. For example, there's the x. And remember, when you're doing something horizontally, you are in fact looking at emphasis on the x. So check it out. There's the emphasis on the x. But don't forget, we had an a value up front. Well, a over 1 could just multiply by a. So there's your a value. There's your vertical stretch. And then your k values all out there. There's your one that's moving it up and down. Check out exponential. This is my personal favorite. I love this because an exponential puts an x as a power. Woo! That's going to be hot, I tell you. Check it out, though. So what does this mean? Well, emphasis on the x. Of course. There's the a value. There's your vertical stretch right up top. But check it out. Check this out. Look. There's that whole part of the function that is all based on x, now in, you got it, in the exponent. The k is out here by itself, in line with everything else, okay? This is what's really, really cool. And in the next podcast, I plan to go through a lot of these things just to show you how they work. Stay tuned.